7.6 focuses on renaming fractions and mixed numbers. Now, the beginning few lessons of this chapter were super easy. These next few lessons get a little bit more challenging just because there are a few steps that we have to follow in order for us to rename our fractions or rename our mixed numbers. Let's go ahead and we're going to take a look first at what a mixed number is and then what a fraction greater than 1 is. A mixed number is a number that's represented by a whole number and a fraction. So in this case we have 2 and 4/6, so 2 would be our whole number and 4/6 would be our fraction. And then we have a fraction greater than 1. So a fraction greater than 1 is a fraction with a numerator greater than the denominator. So you'll notice in this fraction, 16 is greater than the denominator of 6, which means if we were drawing a picture, one whole would have 6 equal pieces. So we notice as we color in all 6 pieces, that would only give us a numerator of 6. So one whole here would be equivalent to 6 sixths. And we see we have 16 sixths. So we have more than one whole, and we're going to have something left over. It's important that we recognize that this denominator determines how many parts are in a whole. So in this case, we would have 6 parts in a whole. And because our numerator of 16 is greater than that, this is a fraction greater than 1. Now, what we need to do with these two different types of ways to represent numbers is we're going to have to be able to change between a mixed number and a fraction greater than 1. We're going to first start with changing from a mixed number to a fraction greater than 1. Then we're going to look at changing from a fraction greater than 1 back to a mixed number. Now, there are two different ways that we can do this. So there are two options that you'll see here. Option number 1. The first thing that we're going to do is convert our wholes into fractions, and then we're going to add all of our fractions together. So for this problem, we see that we have 3 wholes and we have 2 fifths. Now, remember in this last slide when I drew the picture, that denominator, that identifies how many parts are in our whole. So it's really important that we pay attention to our fraction. In this case, our fraction has a 5 in the denominator, which is going to represent the total parts of our whole. Now, we have 3 wholes, so we need to represent 3 wholes as fractions. One whole would be equivalent to 5 fifths, and because I have 3 of them, I need to write 3 5 fifths. And then I would also add my other fraction of 2 fifths. Now each of these pieces are equivalent to one whole. 5 fifths, 5 fifths, 5 fifths, and that's how we get our 3 wholes that we started with. So that's step number 1 for option number 1, and then step number 2 is to add all of our fractions together. We've already talked about adding our fractions. As long as the denominator is the same, the only thing we're going to do is add the numerators. So here we can count by 5s, 5, 10, 15, and then add 2 more, so we would get 17 fifths. So what this is saying is that 3 and 2 fifths is equivalent to 17 fifths as a fraction greater than 1. There's another way to do this. The other way to do this has a few steps that we can draw into our mixed number. So the first step is going to be to multiply the whole number times the denominator. So what I'm going to do is I'm going to draw a multiplication sign here. And that would be my first step. So blue would be my first step. And then my second step is to add the numerator. So then I'm going to put an addition side here, and that would be my second step. After I multiply and add, I'm going to rewrite this new number as the new numerator, and my denominator is going to stay the same. So what I'm going to do first is I'm going to multiply 3 times 5, and 3 times 5 gives me 15. Then I'm going to add 15 plus my numerator, so plus 2 more, and that gives me 17. So this is my new number that I'm working with. Step number 3 says that I'm rewriting this number as my new numerator, and my denominator stays the same. So my denominator of 5 goes over here, and this is my new fraction greater than 1. Notice how it's identical to the fraction greater than 1 above. Either of these options help us convert our mixed numbers into fractions greater than 1. Let's take a look at these steps again with a different mixed number. Here we have 4 and 1/3. So we're going to start with option number 1. So we're going to convert our wholes into fractions. So we have 4 wholes, and we need to figure out what a fraction would be equal to as a whole. Our denominator is a 3, so my wholes are going to be equal to 3/3. And my whole number is a 4, so I need 4 3/3. And then I need to have my 1/3 added to that. My next step is to add all of my fractions together. So 3, 6, 9, 12, plus 1 more is 13. So I have 13/3. That's my fraction greater than 1. My option number 2 involves my multiplication and my addition. So I'm going to start with my multiplication. So I'm going to multiply my 4 times 3. Then I'm going to add my numerator, and then I'm going to rewrite with my denominator staying the same. So my first step is to multiply 4 times 3, and that gives me 12. My second step is to add my 12 plus my numerator of 1, and I get 13. And then my third step is to rewrite this new number as my numerator. So I have 13/3, which you can see is the same as option number 1, just a different way to do it. Either way will work. I want you to go ahead and do this one, choosing either option 1 or option 2. We're going to convert 2 and 5/6 into a fraction greater than 1. All right, I'm going to start with option number 1. So I need to recognize that I have 2 wholes and that my denominator is a 6, so my wholes are going to be 6/6. And I have 2 of them, so 6/6 plus 6/6, and then I need to add my 5/6. And when I add all of these together, 6 plus 6 is 12, plus 5 more is 17/6, so that would be my fraction greater than 1. Down here I'm going to do my multiple steps. I'm going to multiply, add, and then rewrite. So multiply, add, and rewrite with my current denominator of 6. First step is to multiply my whole number times my denominator. So 2 times 6 gives me 12. Next I'm going to add 12 plus 5, and that gives me 17. And then I rewrite my 17 as my new numerator, and I am all done. Either way, I get 17/6. Notice this multiplication piece is the same pretty much as this part here, because I'm adding 6 plus 6. That's the same as 6 times 2. So either way, you're pretty much following those same steps. All right, so that is when we're converting our mixed numbers to fractions greater than 1. Now let's talk about converting fractions greater than 1 to mixed numbers. It's the opposite of what we just did, so we need to follow the opposite steps. So there are, again, 2 different ways that we can do this. The first way involves some addition again. So what we're going to do is we're going to pull out our wholes. We need to identify how many 5/5 are there in 12/5. So 1 5/5 would give me 5. I can add another one because that's going to give me 10. And then if 5 plus 5 gives me 10, I don't have enough to do another 5/5. What I do have left is 2/5. Now what I'm going to redo is I'm going to rewrite my 5/5 as wholes. So 5/5 is equal to 1 whole, 5/5 is equal to 1 whole. I have 2 wholes. So this is going to be 2 wholes, and then my 2/5 stays the same. So what I basically did was pulled out those wholes and then figured out what I have left, which would be the remaining fraction. The other way to do this, option number 2, is through division. So fractions are basically division. This fraction, 12/5, is representing division. What it's representing is 12 divided by 5. So I'm going to divide. How many times does 5 go into 1? It does not. How about 5 going into 12? It goes in 2 times. 5 times 2 gives me 10. I subtract. I'm left with 2, which is my remainder. Now, this is very similar to what we did when we were rewriting our division problems as a fraction. We divided first, and then we rewrote them as our numerator, or our whole number, our quotient, excuse me, became step number 2, says our quotient becomes our whole number. Our remainder, step number 3, becomes our numerator, and our denominator stays the same. Either way we do this, we get 2 2/5. Let's do another problem. I'm going to start with our option number 1, which is pulling out our wholes. Because my denominator is 4, my wholes are going to be equivalent to 4/4. So that's 4, 8. Remember, I can't go over 17, 12, 16. So these 4 4s give me a total of 16, which leaves me with 1 left. Now all of these 4/4 are equivalent to 1 whole. So when I'm rewriting this, I have 4 wholes, and then I have my 1/4 left, and that is my mixed number that represents 17/4. My other way that I can do this is through division. So I'm going to set up my problem. 17 divided by 4. 4 goes into 17 4 times. 4 times 4 gives me 16, and I'm left with a remainder of 1. Now I go to step number 2. So my quotient, that's this part, becomes my whole number. My remainder becomes my numerator, and my denominator of 4 stays the same. Either way you do it, you're going to get the same answer, 4 1/4. Go ahead and give this problem a shot. We're going to, either way you want to do it, whether you're pulling out your wholes or you're doing your division. All right, if we're pulling out our wholes, our 4 in our denominator represents our wholes, so 4/4, that would give me 4. 4/4 would give me 8. And another 4/4, that would give me a total of 12 in my numerator, which leaves me with 1 more. I'm going to rewrite these as wholes, so I have 1 whole, 2 wholes, 3 wholes. So when I rewrite this, I have 3 wholes and 1/4. If I'm dividing, my 4 goes into 13 3 times. 4 times 3 gives me 12. I subtract, I'm left with a remainder of 1. My quotient becomes my whole number. My remainder becomes my numerator, and my denominator of 4 stays the same. Either way, I have 3 1/4. All right, I have a few for you to practice. So for this first one, we're going to write the mixed number as a fraction. Go ahead and do this now. If you're not sure, you should go back and look at your notes. To solve this problem, I'm going to use option number 2. So I'm going to do the multiplication addition method. So I'm going to start with my multiplication, and then I have my addition here. And that's going to help me find my final answer, which is going to have a denominator of 7. So I'm going to write down here 5 times 7. That gives me 35. And then 35 plus 2 more. That gives me 37. And my 37 becomes my new numerator. So I have 37/7. Let's look at our next problem. We're going to write this mixed number as a fraction greater than 1. Go ahead and do that using either of the 2 options. For this problem, I'm going to pull out my wholes. So 1 whole would be equivalent to 5/5 because my denominator is 5. And my whole numbers say I have 3 of them, so I need 3 5/5. And then I'm going to add my 4/5. And when I do that, I have 5, 10, 15 plus 4 more gives me 19/5. And that would be my answer, 19/5. Go ahead and write this fraction as a mixed number. You can use option 1 or option 2, pulling out your wholes or dividing. For this problem, I'm going to go ahead and I'm going to pull out my wholes. So my denominator tells me that my wholes are going to be equivalent to 3/3. So I count by 3s, 3, 6, 9. This gives me 9 as a numerator. And I have 11, so I can only add 2 more. Then I'm going to rewrite my wholes in fractions as whole numbers. So I have 1 whole, 2 wholes, 3 wholes, which gives me my final mixed number as 3 wholes and 2/3. And look at one more for me. Write the fraction as a mixed number. For this one, I'm going to divide. So I'm going to set up my division of 23 divided by 7. And when I do this, 7 goes into 23 3 times. 7 times 3 is 21. I subtract and I'm left with 2, which becomes my new remainder. Now, when I'm rewriting this as a mixed number, my quotient becomes my whole number. My remainder becomes my numerator, and my denominator of 7 stays the same. And my answer is 3 2/7. Okay, that's our lesson for today. What's really important is that we remember these steps. Make sure you have your options written down, you have your steps written down, and you have some examples written down to help you. Whether you're converting fractions greater than 1 to mixed numbers, or you're converting mixed numbers to fractions, the steps are pretty much opposite. Make sure you have those steps written down and you have your definitions for mixed numbers and fractions. See you tomorrow.